Howdy, students! Today we'll talk about protons, neutrons, and electrons, and what effect they have on naming elements. But first, I'd like to tell you I'm going to keep my eye on this guy. See what I did there? All right, current classroom model of the atom, as we've talked about in the past. The nucleus is the smallest volume. It's the largest mass, and in there are the protons and the neutrons. Outside of the nucleus are the circular orbits. That's the largest volume, the smallest mass, and electrons. A view of our current model of the atom. If a nucleus were the size of a period, the edge of the atom would be 2.5 meters away. So look at that period on the page and look 2.5 meters away from you. That's the edge of the atom. Protons and neutrons are in the nucleus. Electrons are in orbitals or orbits around the nucleus. And neutrons bind protons together. Maybe something you haven't thought about before. But neutrons actually hold them together because the positives want to repel each other, but the neutrons keep them together. That's called the strong nuclear force. And atom volume is mostly empty space. There's some electromagnetic fields in there again, but it's just mostly empty space. And Millikan, a scientist we haven't really talked about, but know that he discovered protons are 2,000 times the mass of electrons, which is why we don't count the mass of electrons in the mass of our atoms. So, some atomic particles. Electrons, you can use the symbol E minus, protons P plus, neutrons N naught or N0. Charges -1, +1, and 0. Again, the mass, we could get right down to it. It's 9.1 times 10 to the negative third kilograms, 1.673 times 10 to the negative 27th kilograms, and 1.673 times 10 to the negative 27 kilograms. We've made it easier on you. Instead of remembering these tiny little numbers, all you remember is protons have 1 AMU or atomic mass unit, and neutrons have 1 AMU or atomic mass unit. So how to read the periodic table. The name is going to be written out like carbon is here. The atomic number is always an integer, always a whole number. Then you have the symbol. It's going to be one capital letter and possibly one lowercase letter after that. The average atomic mass, that's why it's got a decimal. But if you wanted to just use the periodic table, you would round to the next whole number. Next, the closest whole number. So if it was 12.85, then you would round to 13. And then also, we will use this, but we don't need to know it now, is electronegativity. Don't worry about it just yet. What does this all mean? The name is the official name given to the element. It's actually a rigorous process. Some of them came a long time ago and were discovered before we knew what elements were, but some of them just came along later. Einsteinium obviously came late in the game. Symbol is the official symbol just to make it easier on us. Sometimes it's similar to the name, sometimes it pays tribute to the ancient name. PB, lead, contains none of those letters, but it's plumbum actually is where we got PB from. But the first letter is always capitalized, the second letter is never capitalized. An atomic number, this is the number of protons. That's the identity of the element. If you change the protons, you change the element. You can add a proton to carbon, but it's not carbon anymore. Now it's nitrogen. So let's talk about elements versus isotopes. Average atomic mass, it's not a whole number because it's a calculated average. Dalton said all atoms of an element are identical. We know this is not correct. Atoms of the same element might have different number of neutrons. Neutrons make it an isotope. Isotope is just exactly the same protons, but a different number of neutrons. An atomic mass number is a whole number because it speaks of one individual atom. So remember, atomic mass is an average. Mass number is going to be 12 or 13, 49. Atomic mass is going to be 12.01 or 35.43. It's going to be some decimal because it's an average. And the number of neutrons you can calculate if you have the atomic mass or the mass number. You subtract the mass number or the number of protons from the atomic mass, and that gives you the number of neutrons because the atomic mass is the neutrons and the protons together. So let's talk shorthand notation. If you want to talk about a symbol, you will use this notation. Where the X is always where the element is going to be. The atomic number, the number of protons, is going to be down here, and the mass number is going to be down here. So which one's always going to be higher, A or Z? That's right. A, 35, 36. These are isotopes of each other because they have the exact same number of protons, which identifies the element, but they have a different number of neutrons, which is why they have a different mass number. Remember, mass number is number of protons plus the number of neutrons. But in an isotope, this is going to be different, and this is always going to be bigger. Top is higher. Shorthand notation. Let's try a little problem here. How many protons does oxygen have? How many neutrons does oxygen have? How about the number of electrons? Yeah. It has, let's choose red, 8 protons. Oh, that's good writing. It has 16 minus 8 electrons equals 8. Oh, man, that's good. And because it's neutral, we know it's got the same number of protons as electrons, so it's 8. All right. Another problem. Ooh, a little tougher here. How many protons are there? Well, right away, I see the 80, the atomic number. How many neutrons? A little tougher, but now we have rounded to 1 minus 80, which means we have 121 neutrons. And how many electrons? Well, it's not 121. It needs to balance out the protons. So again, we have 80. Look at that. Let's talk about ions. So an atom is, if it has a charge, it is an ion. Cations have a positive charge. I always remember this as cats have paws, or I like cats. As you may have heard from videos prior, I have one, a little Telly, happy little guy, but cats have paws. So if you see a 2+, that is a positive charge. It is a cation, and it has lost electrons. Think about it. Can it change the number of protons? No. So in order to have more protons than electrons, in order to have more pluses than minuses, it has to lose electrons. Anions, you can remember, negative ion is the opposite. It's going to have a negative charge on it, and it has gained electrons. Remember, protons aren't going to change. Oxygen is always going to have 8 protons, but if it gains 2 electrons, then it is going to have a negative charge. So I'd like you guys to complete this table. You're going to get plenty of practice here. Practice makes perfect. It'll make you very, very good. Work on this. This is everything that you need. Figure out the mass number, atomic number, number of protons, number of neutrons, and number of electrons. We'll do the first one together. So chlorine, we can tell from this isotope symbol, has 35 for its mass number. The atomic number right here is 17. And the number of protons, always equal to this guy, 17. Number of neutrons is a little bit tougher than just looking at a number. We get the number of neutrons from the mass number minus the atomic number. Let's see, that's 25. 25 minus 7 is 18. And we see no charge here like we see down here, so we know the number of protons equals the number of electrons, and we're at 17. All right, you do the other ones, and again, practice makes perfect. That's all you're going to have to do in order to get better at this, to get good at this. Do it, check your answers, make sure you get this stuff. And I really hope that was helpful.